So guys, in today's video we are going to learn something about nucleophilic addition reaction itself, but with respect to a different concept, that is what will happen when carbonyl compounds are treated with ammonia and its derivatives. I repeat, so in today's video we are going to look after the nucleophilic addition reactions of ammonia and its derivatives with respect to your carbonyl compounds. So let's begin with the topic saying as addition of ammonia and its derivatives. Remember, it is also falling under the category of nucleophilic addition reaction. Please mark my words, nucleophilic addition reaction. Because whatever the product we are going to get, it will be an addition product. It is neither a substitution nor an elimination. I am repeating, it is an addition. ಒಂದು ಯಾವುದೋ ಒಂದು ಆಟಮ್ ಆಡ್ ಆಗ್ತಾ ಉಂಟು, ಯಾವುದೊಂದು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಇಲ್ಲ, ಯಾವುದನ್ನೊಂದು ಎಲಿಮಿನೇಟ್ ಮಾಡ್ತಾ ಇಲ್ಲ. ಆಗ್ತಾ ಇರೋದು ಆಡ್ ಯಾವುದು? ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್. ಅದನ್ನೇ ನಾವು ಇಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡ್ತಿದ್ವಿ, ಬಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಡಿಫ್ರೆಂಟ್ ಹೆಡ್ಡಿಂಗ್. ಹೈಡ್ರೋಜನ್ ಸೈನೈಡ್ ಅಲ್ಲಿ ಕೂಡ ಯಾವ ತರ ನೋಡಿದ್ವಿ, ಅದೇ ರೀತಿ ಸೋಡಿಯಂ ಬೈಸಲ್ಫೈಟ್ ಅಲ್ಲಿ ನೋಡಿದ್ವಿ, ಆಲ್ಕೋಹಾಲ್ಸ್ ಅಲ್ಲಿ ನೋಡಿದ್ವಿ ಅಲ್ಲ, ಅದೇ ರೀತಿ ಇದು ಕೂಡ ಒಂದು ಸೆಪರೇಟ್ ಕಾನ್ಸೆಪ್ಟ್. ಆದ್ರೆ ನಾವಿಲ್ಲಿ ಒನ್ ಬೈ ಒನ್ ಅಮೋನಿಯಾ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ ಮತ್ತು ಡಿರೈವೇಟಿವ್ಸ್ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. ದಟ್ ಇಸ್ ಅ ಸಿಂಪಲ್ ಲಾಜಿಕ್ ವೇ. But before going to the reactions, I would like to make you certain things clear over there. What is that? First important thing you remember, so whenever the carbonyl compound is being treated with ammonia and its derivatives, the reaction is in equilibrium. So first ಏನಾಗುತ್ತೆ, as soon as your carbonyl compounds is reacting with an ammonia and its derivatives, ಆ ಒಂದು equilibrium condition ಆಗೋದ್ರಿಂದ ನಮಗೊಂದು ಫಸ್ಟ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಬರುತ್ತೆ. Okay, and afterwards the dehydration of this intermediate, that is dehydration ಅಂದ್ರೆ ಇದರಿಂದ ಈ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಇಂದ ನಾವು ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ ನ ತೆಗೆದಾಗ ನಂಗೆ ನನ್ನ ಅಡಿಷನ್ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ, which will be in the form of C double bond NZ. ಸಾರ್ ಹಾಗಾದ್ರೆ ಎಲ್ಲದಕ್ಕೂ ಸೇಮಾ? ಎಸ್, ಎಲ್ಲದಕ್ಕೂ ಸೇಮೆ. ಆದ್ರೆ ಮೇಜರ್ ಆಗಿ ನೋಡಿ ನಾನು Z ಏನ್ ಬರೆದಿದ್ದೇನಲ್ಲ, this will keep on changing. Z depends upon what type of an ammonia, what the other reactant you have taken. Whether ammonia na aವಾಗ Z1 ಬರುತ್ತೆ, ಇಟ್ಸ್ ಡಿರೈವೇಟಿವ್ಸ್ ಬೇರೆ ಬೇರೆ ಬಂದಾಗ ನೀವೇನ್ ನೋಡಬಹುದು, Z ಚೇಂಜ್ ಆಗ್ತಾ ಬರ್ತಾ ಇರುತ್ತೆ. ಆದ್ರೆ ಒಂದು ಕಾಮನ್ ಆಗಿ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ, ಈ C ಡಬಲ್ ಬಾಂಡ್ N ಎಕ್ಸಿಸ್ಟ್ ಅಂತೂ ಆಗಿರುತ್ತೆ ನಮ್ಮ ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ಅಲ್ಲಿ. Okay, it's a common thing. C double bond N part will be there. The Z will be keep on changing as you're changing with its derivatives. Okay, as I mentioned, since the reaction is undergoing with respect to the dehydration, so the reaction is overall catalyzed by acids. So these are the two important things one has to know before going with the reaction. If you have not understood these two things, we'll come to know when we are dealing with the reaction. So let us first begin with ammonia. Okay, I'm taking my ammonia. So when I'm writing my ammonia, how can I write? I can write it as NH3 alva. This is our ammonia gas in the Haber's process, the same ammonia we are using. But now see guys, you have to pay attention when I am writing the reaction. Okay, because the way I am writing the reaction will be very much helpful for you in order to understand it and also to write in your exams. Okay, if you better understanding means easily you can ink it on your paper. So first one, I'm going with my ammonia. So first let me take with my aldehyde. As I have said, I have to use this one with my carbonyl compound. So particularly I'm choosing first my aldehyde as a carbonyl compound. So I'm writing my NH3 in this way. Just notice over here, HNH2. The same way, nothing is different, just for my easier understanding and for also to understandable for you, I'm writing in this way. As I mentioned, first will be an equilibrium. So this reaction is in equilibrium. Okay, ಇಷ್ಟು ಫಾರ್ವರ್ಡ್ ಹೋಗುತ್ತೆ, ಅಷ್ಟೇ ಬ್ಯಾಕ್ವರ್ಡ್ ಬರೋ ಸಾಧ್ಯತೆಗಳು ಇರುತ್ತೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಏನಾಗುತ್ತೆ ನೋಡಿ, ಆಸ್ ಐ ನೋ, ಈಗ ಏನಾಗುತ್ತೆ, ಈ ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಕ್ಸಿಜನ್ ತನ್ನ ಕಡೆ ಕಳ್ಕೊಳ್ಳುತ್ತೆ. ಯಾಕೆ? ಬಿಕಾಸ್ ಕಂಪೇರಿಟಿವ್ ಟು ಕಾರ್ಬನ್ ಅಂಡ್ ಆಕ್ಸಿಜನ್, ಆಕ್ಸಿಜನ್ ಇಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ನೆಗೆಟಿವ್. ಎಸ್, ಅಂಡ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ನೌ, ಕಾರ್ಬನ್ ಗೆಟ್ಸ್ ಅ ಡೆಲ್ಟಾ ಪ್ಲಸ್. ಸೊ ಫಸ್ಟ್ ಏನಾಗುತ್ತೆ, ಈ H ಯಾಕೆ ಬರ್ದೆ ಅಂದ್ರೆ, ದಿಸ್ ಇಸ್ ಗೋಯಿಂಗ್ ಔಟ್ ಆಸ್ ಅ H ಪ್ಲಸ್. ಐ ರಿಪೀಟ್, ದಿಸ್ ಪಾರ್ಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಔಟ್ ಆಸ್ ಅ H ಪ್ಲಸ್. ಸೊ H ಪ್ಲಸ್ ಏನ್ ಮಾಡುತ್ತೆ, ಇದು ತುಂಬಾನೇ ಬೇಗ ಬರೋ ಕಾರಣದಿಂದ ಮೈನಸ್ ಇಲ್ಲಿ ಉಂಟಲ್ವಾ, ತನ್ನ ಕಡೆಗೆ ಎಳ್ಕೊಬಿಡುತ್ತೆ. ಸೊ ಅವಾಗ ಏನ್ ಬರೀಬಹುದು ನೀವು, R C ಸಿಂಗಲ್ ಬಾಂಡ್, ಡಬಲ್ ಬಾಂಡ್ ಅಲ್ಲ ಸಿಂಗಲ್ ಬಾಂಡ್, ಯಾಕಂದ್ರೆ ಡಬಲ್ ಬಾಂಡ್ ಇನ ಒನ್ ಬಾಂಡ್ ಆಕ್ಸಿಜನ್ ಹೇಳ್ಕೊಂಡಿದೆ. ಸೊ ಹಿಯರ್ ಯು ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ ಆಸ್ ವಾಟ್ OH. ಸೊ ಸೊ ನಾವು ಯು ಜಸ್ಟ್ ಸಿ, ಇವಾಗ H ಹೊರಗೋಗಿದೆ ಅಂದ್ರೆ ಇದಕ್ಕೆ ಏನ್ ಬಿಡ್ತು, ಈಗ ಮೈನಸ್ ಬಿಟ್ಟಿರುತ್ತಲ್ಲ. ಸೊ ಈಗ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಇಸ್ ಮೋರ್ ಆನ್ ದಿ ನೈಟ್ರೋಜನ್, ಇದು ಪ್ಲಸ್ ಉಂಟು ಕಾರ್ಬನ್ ಮೇಲೆ. ಸೊ ಇದೇನ್ ಮಾಡುತ್ತೆ, ನೈಟ್ರೋಜನ್ ಬಂದೀಗ ಇಲ್ಲಿಗೆ ಅಟ್ಯಾಚ್ ಆಗುತ್ತೆ. ಬಟ್ ಅಲಾಂಗ್ ವಿತ್ ದಿ ನೈಟ್ರೋಜನ್ ಇಸ್ ಆಲ್ಸೋ ಬ್ರಿಂಗಿಂಗ್ ಅಲಾಂಗ್ ವಿತ್ ಇಟ್ 2 hydrogens. So let me write it in this way itself for better understanding. NH2. NH2. Don't forget to write this H. Okay, many times you forget it. You write this. As I have mentioned, first ಏನಾಯ್ತು ನಂಗೆ intermediate ಬಂತು. So this is my intermediate part. Okay, let me write it in my square brackets for better understanding. So next ಏನ್ ಮಾಡಬೇಕು, ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ಬರಬೇಕು ಅಂದ್ರೆ ನೋಡಿ ಯಾವ ತರ ಬಂದಿದೆ ಅದೇ ರೀತಿ ಬರುತ್ತೆ ಅಂತ ನಾವು ಟೆಸ್ಟ್ ಮಾಡೋಣ. So now next part, ಇದನ್ನ ಡಿಹೈಡ್ರೇಟ್ ಮಾಡಬೇಕು. As I have said, it is catalyzed by acid. So in the presence of H plus, what happens? You will be removing the water. Now the question arises, from where does the water goes? Remember, ಈಗ OH ಹೊರಗೆ ಹೋಗ್ತಾ ಉಂಟು as OH minus. H2 ಅಂದ್ರೆ ಅರ್ಥ ಏನು, is in the form of H plus plus OH minus. So OH is going out. So along with the out, it is also taking its electrons. So ಕಾರ್ಬನ್ ಮೇಲೆ ಏನ್ ಬಂತು, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬಂತು. ಸೊ ಅವಾಗ ಏನಾಯ್ತು, ಇದು ಅನ್ಸ್ಟೇಬಲ್ ಆಗ್ತು. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ನೈಟ್ರೋಜನ್ ಮೇಲೆ ಇರೋ ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೊಡುತ್ತೆ. ಸೊ ಅವಾಗ ಏನಾಯ್ತು, C ಡಬಲ್ ಬಾಂಡ್ N ಆಯ್ತು. ಬಟ್ ಇಟ್ ವಿಲ್ ನಾಟ್ ಸ್ಟಾಪ್. ಈಗ ನೈಟ್ರೋಜನ್ ಮೇಲೆ ಪ್ಲಸ್ ಬಂತು, ಅದು ಇಷ್ಟಪಡಲ್ಲ. ಸೊ ಅವಾಗ ಏನ್ ಮಾಡುತ್ತೆ, ಈ ಹೈಡ್ರೋಜನ್ ನ ಒನ್ ಎಲೆಕ್ಟ್ರಾನ್ ತನ್ನ ಕಡೆ ಹೇಳ್ಕೊಳುತ್ತೆ, ಸಾರಿ ಈ ಬಾಂಡ್ ನ ತನ್ನ ಕಡೆಗೆ ಹೇಳ್ಕೊಳುತ್ತೆ. ಅವಾಗ ಏನ್ ಹೊರಗಡೆ ಹೋಯ್ತು, H ಪ್ಲಸ್ ಹೊರಗಡೆ ಹೋಯ್ತು. ಸೊ OH ಮೈನಸ್ ಹೊರಗೋಯ್ತು, H ಪ್ಲಸ್ ಹೊರಗೋಯ್ತು. ಆದ್ರೆ ಒಳಗಡೆ ಯಾವ ತರ ರಿಅರೇಂಜ್ಮೆಂಟ್ ಆಗ್ತಾ ಉಂಟು ನೋಡಿ, R ಉಂಟಾ, R ಉಂಟು, OH ಇಲ್ಲ, OH has gone out as OH minus, but it has been forming what, C double bond N. So R single bond, C double bond, N and H. And many times what we forget, see this H is remaining, so I will be writing my H. Are you able to notice now? So when I am taking as ammonia, I am getting my Z as what over here, H part. So here Z is H and all rest is same, C double bond N is existing. Remember, this product is called as what, imines. This product is called as what, imines. So remember, whenever a carbonyl compound is treated with an ammonia, the final nucleophilic addition product you are getting is what, imines. And one of the common mistake what we do is we forget to write this H, is one common thing. And the second most common thing what we do is H ಪ್ಲಸ್ ನೈಟ್ರೋಜನ್ ಇರಕ ಹೈಡ್ರೋಜನ್ ಹೋಗ್ಬೇಕೆ ವಿನಃ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಈ ಹೈಡ್ರೋಜನ್ ಕಳಿಸ್ಕೊಡ್ತೀವಿ. ದಟ್ ಇಸ್ ಕಂಪ್ಲೀಟ್ಲಿ ರಾಂಗ್. ಅದಕ್ಕೆ ನಾನು ನಿಮ್ಗೆ ಕರೆಕ್ಟ್ ಆಗಿ ಹೇಳಿದ್ದೀನಿ. OH ಹೊರಗಡೆ ಹೋದಾಗ OH ಮೈನಸ್ ಆಯ್ತು, C ಮೇಲೆ ಏನ್ ಬಂತು, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬಂತು. ನೈಟ್ರೋಜನ್ ಮೇಲಿರೋ ಲೋನ್ ಪೇರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೊಟ್ಟು ಡಬಲ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ನೈಟ್ರೋಜನ್ ಮೇಲೆ ಪ್ಲಸ್ ಬಂತು, ಅವಾಗ ಈ ಹೈಡ್ರೋಜನ್ ತಗೊಳಕ್ಕಾಗಲ್ಲ, ತನ್ನ ಹತ್ರ ಇರೋ ಹೈಡ್ರೋಜನ್ ಒಂದ್ ಬಾಂಡ್ ನ ತನ್ನ ಕಡೆಗೆ ಹೇಳ್ಕೊಳುತ್ತೆ. ಅವಾಗ ಏನಾಯ್ತು, H will come as H plus and OH minus forms H2O. So it will be forming alternatively C double bond NH. Is that clear? Can you please take a pen and a paper and solve with me now? Let us take now ketone. Let's play with the ketone part. R, C double bond O and a R. The same way you write with ammonia itself. So how am I writing? H, NH2. First is what? Equilibrium reaction. Yes or no? ಸೊ ಫಸ್ಟ್ ಏನಾಗುತ್ತೆ, O ಮೈನಸ್ ಆಯ್ತು, ಈ H ತನ್ನ ಕಡೆ ಗೆಲ್ಕೊಳ್ಳುತ್ತೆ, ಈ ನೈಟ್ರೋಜನ್ ಇಲ್ಲಿಗೆ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ. ಎಸ್ ಆರ್ ನೋ? ಸೊ ನಾವು ಯು ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಎಸ್ ವಾಟ್, R, C, O, H, N, H and a H. Don't forget this R. Here you are having one R. So now what you will be having, so with the help of acid, water will be lost. So ಈಗ OH is going out as a OH minus. This carbon will be getting a positive charge. In order to balance this charge, whatever the lone pair of electrons was, that would be given. So nitrogen will be having a positive charge. In order to balance that positive charge, this bond will be taken by your nitrogen. So now H plus will be coming out. H plus and OH minus is forming water. But what has happened? A double bond has been formed. The final product, how I am getting, R, C, R. So I have written this part, R, C, R. So double bond is there, double bond, N and a H. Able to see? So in both the cases, when you're treating with the ammonia, Z is your H. Z is over here is a H. ಈ ಎರಡು ಪಾರ್ಟ್ ನ ಬರ್ದಿಲ್ಲ. ಆಲ್ಡಿಹೈಡ್ಸ್ ತಗೊಂಡಾಗ ಒಂದು H ಆಗಿರುತ್ತೆ, ಕೀಟೋನ್ಸ್ ತಗೊಂಡಾಗ ಎರಡು R ಆಗಿರುತ್ತೆ. So this is the way of representation. If you remember in this way, easily you can crack any of the addition product of ammonia and its derivatives. Is that clear? So what we came to know is, so whenever a carbonyl compounds are treated with an ammonia, first it is going to give an intermediate. It is a general case. On dehydration of that intermediate, we are getting a product which is called as what? Amines, which is generally having the formula as C double bond NH. C double bond NH. So whenever a group you are having a C double bond NH, so this group C double bond NH, it is called as what? Amines. It's called as amines. So when you are getting amines, whenever a carbonyl compound is treated with ammonia. Is that clear? Okay. So next, derivative. Now let us talk about derivatives. So what do you mean by derivatives? Of course, now ammonia ಇಂದ ಈಗ ಒಂದು H ತೆಗ್ದಿ ಅದಕ್ಕೆ ನಾವು ಯಾವ್ದಾದ್ರು ಒಂದು ಬೇರೆದ್ನ ಆಡ್ ಮಾಡಿದ್ರೆ, okay, alkyl group, hydroxy group, so they will be called as what? Derivatives. Derivatives means what? Derivation means what? By utilizing certain thing, we are extracting out something else. The same way here on the derivatives of ammonia means what? Ammonia is the main reactant, but by utilizing ammonia we are taking some other reactants. We are making some other reactants from that main reactant. So we are deriving other reactants from the ammonia. So it is called as what? Derivatives of ammonia. So one such derivatives we'll look after. It is called as with amines. Mark my words, with amines. So generally amines, and first I'll write my representation RNH2. So how we have written amines? RNH2. Okay, now let us start with the same protocol as we have done earlier. So when I am writing my amine, you just pay attention how I am writing. Ammonia barathina heng barde HNH2. So I am putting my one H out, alva. The same way we are going to follow over here. Just pay attention. First let me take my normal aldehydes, RC double bond O and a H, plus I am going to write my my amines in this way. H NH R. Are you able to see? H NH R. So first the equilibrium reaction, it goes up. Nitrogen is going to attack this carbonyl carbon. So you're going to get as R C O H. So no. See, pay attention. In ammonia we were having as a NH2. Now here we are having one as a H, another as a R. Yes or no? And as usual, one more H. Now when you're removing the water, as of course I have said, now this will go out. Nitrogen, now carbon will be having a positive charge. Okay, OH minus ಹೋಗೋದು ಅಂದಾಗ valency satisfy ಮಾಡಕ್ಕೆ ಏನು ಮಾಡುತ್ತೆ? Nitrogen ತನ್ನ lone pair of electrons ಕೊಡುತ್ತೆ. ಈಗ ಕ್ವೆಶ್ಚನ್ ಅರೈಸ್ ಆಗೋದು, ಇಲ್ಲಿ ಹೆಂಗು ಎರಡು H ಇತ್ತು, ಸೊ ಅವಾಗ H is going out. ಇಲ್ಲಿ ಈಗ ಒಂದು H ಉಂಟು R ಉಂಟು. Do remember when we are comparing your alkyl group and your H, of course in this case your hydrogen is a better leaving group. So now what it will do, in order to balance this, now this part will be taken by your nitrogen. So how we can write? One is R C H. So I have written this part, R C H. Of course now here there is a double bond character, double bond N and a R. Getting my point? So R C H double bond N R. So generally this representation is called as our Schiff's base. What it is called as? Schiff's base. So whenever you're treating your carbonyl compounds with the amines, the final addition product we are getting is called as what? Schiff's base, which is having a general representation as C double bond NR. E part is navenanta heltivi Schiff's base. One of the present wide variety of the inorganic drugs, whatever we are preparing, or whatever the organic drugs we are preparing, generally they will be having this Schiff's base functional group. Okay, for the cancer treatment, wide variety of drugs, whatever we are using, generally this group will be present in those medicines. Okay, so that Schiff's base we are going to obtain over here. You can just see that how we are obtaining in a simplest way is this one. Whenever you are treating your carbonyl compounds with your amines, after dehydration of your intermediate, the final product, whatever you are getting is a Schiff's base. Remember, with amines. If I go further, let me take my ketones, R C double bond O and a R. So how you write it? H dot NHR. So no. So it is an equilibrium. Yes. So first ಏನಾಗುತ್ತೆ RCOH and a R. Here you are having as a N, H and a R. So when you're treating with our acid, water has to go out, so OH will go out, positive bantu, nitrogen tan ಮೇಲೆ lone pair of electrons ತಗೊಳುತ್ತೆ, nitrogen ಮೇಲೆ plus bantu, this bond will be taken by your nitrogen, so ಇಲ್ಲಿ ಏನಾಯಿತು double bond form ಆಗಿದೆ, so R C R double bond N R. Once again, whatever you're getting will be our Schiff's base. So Schiff's base, this is very much important. This represents our Schiff's base. C double bond NH ididre, it is amines as we have seen over here. Ade H ಜಾಗದಲ್ಲಿ ಎಲ್ಲ ಅದು ನಿಮಗೆ R ಬಂದ್ರೆ, that is our Schiff's base. Now you just see when I said as a final product, ಈಗ Z ನೋಡಿ amine ammonia ತಗೊಂಡಾಗ Z ಜಾಗದಲ್ಲಿ R ಇತ್ತು. ಅದೇ ನೀವು ಯಾವಾಗ ನಿಮ್ಮ amines ನ ತಗೊಂತಾ ಇದ್ದೀರಾ, amines ನ ತಗೊಂಡಾಗ Z ಜಾಗದಲ್ಲಿ R ಬಂತು. But in all the cases we are having what? C double bond in character. Able to see? So that was the reason I have given you just general representation. In case we miss also some case, so you have to remember that where we have missed. C ಮತ್ತೆ N ಮಧ್ಯೆ double bond ಬರಲೇಬೇಕು. Is that clear? So this was another important derivative. And what we came to know, whenever a carbonyl compounds are treated with your amines, yes, first you're going to get an addition product. On dehydration of that addition product, the final on dehydration of your intermediate, the final product whatever we are getting is called as our Schiff's base. It's called as what? Schiff's base. They can ask you a question, how can you obtain Schiff's base from carbonyl compounds? So you should remember, and you have to remember this reaction. So when a nucleophilic addition reaction is taking place between carbonyl compound and that of your amines, these important words, ಇದು ಅಮೋನಿಯಾ ಡಿರೈವೇಟಿವ್, ಯಾಕೆ NH3 ಇದು ಒಂದು H ನ ರಿಪ್ಲೇಸ್ಮೆಂಟ್ ಆಲ್ಕಿಲ್ ಗ್ರೂಪ್ ಹಾಕಿದ್ದೀನಿ, or aryl group, whatever it may be. So they will be called as what? Amines. The general amine ನೀವು ನೋಡಬಹುದು as aniline. Yes. So this is called as what? Aniline. So this is also can be an example of your amines also, because R is what? C6H5. I think much we have made a mistake. There is no mistakes in here. So here R comes here, alkyl or an aryl system. General representation I have given you as RNH2. Okay. So when we have treated with an ammonia, the final addition, nucleophilic, I have to mention as a nucleophilic addition product, we are getting as amines. Hinge amines in the by this representation. C double bond NH mainly indicates our amines. So whenever we are treating our carbonyl compounds with amines, you're getting what? Schiff's base. How do we come to know about Schiff's base? C double bond NR. So this represents our Schiff's base. Wide variety of the drugs for the treatment of the cancer generally have this group in them. Okay, Schiff's base is one of the most, we can say, anti-cancer agent, which is hardly working in present scenario. Okay, now let us go with another important derivative, that is with hydroxyamine. With hydroxylamine. So guys, now first let us look after how to write this hydroxylamine. You just see NH2OH. NH2OH. So generally this is called as what? Hydroxylamine. So ammonia NH3 ಇದ್ದಿದ್ದು ಒಂದು H ನ ತೆಗೆದಾಗ NH2 ಆಗುತ್ತಾ, ಆ H ಬದಲು ಏನು ಹಾಕಿದೆ? OH ಹಾಕಿದ್ದೀನಿ. ಅಮೈನ್ಸ್ ಅಲ್ಲಿ ಏನು ಮಾಡಿದೆ? ಆ H ಜಾಗದಲ್ಲಿ R ಹಾಕಿದೆ. ಹೈಡ್ರಾಕ್ಸಿಲ್ ಏನ್ ಮಾಡಿದೆ? ಆ H ಜಾಗದಲ್ಲಿ OH ಹಾಕ್ತಿದ್ದೀನಿ. So these are the ways you have to remember. Okay. So now let us deal with it. So first let us talk about our aldehydes. RC double bond O and a H. So as I mentioned, how are you going to write it? See, ಒಂದು H ನ ಹೊರಗೆ ಬರ್ಕೊಬಿಡಿ. ಈ NH2 ಗ್ರೂಪ್ ಜೊತೆ ಯಾವ್ದು ಇರುತ್ತಲ್ಲ ಆ H ನ ಹೊರಗೆ ಬರ್ಕೊಳ್ಳಿ. H ಬರ್ಕೊಂಡ್ರ, then what? NHOH. As usually I have got NH2OH. See, in all the cases I have done the same thing. I have written the hydrogens which will associate with the nitrogen itself. ಇಲ್ಲಿ ಕೂಡ ನೋಡಿ, H from which hydrogen I have taken the hydrogen which is bonded to my nitrogen. Of course, till here there was no confusion, but here you are having two hydrogens, illo hydrogens into illo hydrogen. But do remember, for our understanding, better understanding, you have to remove the hydrogen in this way, that is which has been attached with the nitrogen. Are you able to see how we are writing? It will be easy for you to write. So again, I would tell the pi electrons will be attracted for oxygen. Yes. So whatever now electron density on the nitrogen will be more, so that is going to attack our carbonyl carbon. So here you will be getting as an R, C single bond OH. Here one H as it is. So N is there. Along with N, now what is it? This H is not there because it has gone over here. So one H is there, another OH is there. So this is our intermediate. So when you're treating this one in the presence of H plus, so dehydration takes place. So OH is going out. So no, OH is going out. So carbon now will be having a positive charge. By utilizing the lone pair of electrons on nitrogen, it would be given, forming a double bond. Now nitrogen will be having a positive charge. In order to now balance that one, this electrons will be pulled towards the nitrogen. So no. So now you just see how we're going to write. R is there, C is there, C is there, H is there, H is there. Now it's between C and N, by utilizing the lone pair of electrons on nitrogen, it has formed a double bond. C double bond N I am having. H has gone out, has H plus. There is a reason it has been coming and giving out as a water. Then along with the H, you are having your OH. Along with N, you are having our OH. Remember, this part is called as what? Aldoxime. Aldoxime. What it is called as? Aldoxime. Okay. See here, what is this Z? Here it is OH. As I have mentioned, with respect to the derivatives, you will be getting a different Z, alva. As we have seen over here, this is our general representation of our nucleophilic addition product. Whenever your ammonia and its derivatives are reacting with our carbonyl compounds. When you talk about ammonia, the Z was H. When you talked about your amines, the Z was R. Now when we are talking about your hydroxyl amine, you can just see that the Z is OH. And whatever the addition product you are obtaining when you are treating aldehyde with hydroxylamine, it is called as what? Aldoxime. What it is called as? Aldoxime. Coming now with respect to the ketones, as we have did earlier. So R, C, double bond, O and a R. Yes. So now this one, when it is treating, you just write in the same way. H, NH, OH. Yes. So NH to OH. Nothing I am making a difference. So first the reaction will be in equilibrium. Please mark my words. First part will be in equilibrium. So as usual, this will be pulled by oxygen. Nitrogen is going to attack this carbon. So you'll be getting as an RCOH. Yes. So here you'll be having as an N, one H, because this H, and one OH. This OH, this H has gone over here. So as usual, one more R. So on dehydration, minus water, so OH goes out. Carbon will be getting a positive charge. Utilizing the lone pair of nitrogen, it will form a double bond in order to balance the valency of carbon. Now nitrogen may have a positive charge, it comes. In order to balance that valency, this electrons will be pulled towards the nitrogen. So in that case, what happens? H will come out as H plus. So H plus and OH minus forms H2O. So now here you'll be getting R, C, R. Yes or no? R, C, R, you'll be getting double bond NOH. Remember, it is called as what? Ketoxime. Ketoxime. So whenever an aldehyde is treated with an hydroxylamine, the final nucleophilic addition reaction you're getting was aldoxime. Aldehyde gives you aldoxime when you're treating with hydroxylamine followed by dehydration. Very much important. First one intermediate you're getting intermediate dehydrate madre matra, you're getting your aldoxime. Similarly, when your ketones are treated with your hydroxylamine followed by dehydration, it gives you what? Ketoxime. Ketone in the ketoxime. Aldehyde in the aldoxime. Generally, if I talk about the C double bond NOH, when I'm taking just this part, so C double bond NOH, generally they are called as what? Oximes. Generally they are called as what? Oximes. Able to understand? So what we came to know, whenever a carbonyl compounds are treated with hydroxylamine, I repeat, with a hydroxylamine, the final nucleophilic addition product you're getting as what? Oximes. So in this video, I'm just covering only the three important ammonia and its derivatives. In my next video, I will be going with the other derivatives, not in order to not to confuse you, but I'll just have a revision now. So today in this video, we have just looked after addition of ammonia and its derivatives. Yes, and remember it is also falling under the category of your nucleophilic addition reaction itself. And what we came to know that this reaction, that is when your carbonyl compound is treated with the ammonia and its derivatives, first the reaction will be in equilibrium. It will be giving you an intermediate, which on dehydration gives us the respective addition product. General representation of whatever the addition product we are getting, it will be having as a C double bond NZ. This Z value, it will be keep on changing with respect to the whatever the derivatives and the ammonia you are going to choose, as we have seen. And very much important, overall this reaction is catalyzed by that of your acid. Okay, so to begin with, we have started with ammonia, and we came to know that ammonia means, it is the general formula is how we are writing NH3. Yes, but in order to make our reaction to look easier and to follow easily, I am splitting my NH3 as HNH2. What I am presenting as HNH2. Overall the same, it is NH3 itself, but for my easier understanding I have done so. Of course, we know the electronegativity between carbon and oxygen is highly differences there. So oxygen is going to pull its pi electrons. So in order, carbon gets a positive charge. So this H is going to come out as a H plus. So whatever the bond was there, the bond that will come on nitrogen, electron density will be high on the nitrogen. So it is going to attack our positively centered carbon atom. Overs negative, it will attract your H plus. As we have seen, this is your intermediate. Then soon after what happens, dehydration of the intermediate takes place in the presence of an acids. Yeah, H plus. So here what happens, OH is going out as OH minus, that is, it is taking along with it the bonded electrons to along with it. So carbon will be having now positive charge. In order to balance the positive charge, what it will do, nitrogen, by utilizing its lone pair of electrons, because we know NH3, of course the nitrogen will be having your lone pair of electrons. So by utilizing that lone pair of electrons, it will now form a double bond between your carbon. So when it forms, it will satisfy the valency of the carbon. But in turn, what happens now, nitrogen, by giving its lone pair of electrons, it will be having now positive charge. In order to balance that positive charge, what it will do, it will attract the bonded pair of electrons which has been bonded with the nitrogen towards itself. So now H plus will come out. So H plus and OH minus goes out and forms a water. That is the reason it is called as what? Whatever the product we are obtaining, it's a condensation products. Condensation products means like your water, there are small molecules, it is going out. Condensation product antanu ಹೇಳ್ತಿಕ್ಕೆಲ್ಲ ಸರಿ ನಾವು. So when it is going out, the final product, whatever you're getting, is called as what? Imines. That is RCH double bond NH. The C double bond NH generally represents the general has a name called as what? Imines. Please mark my words. It's called as what? Imines. Coming with respect to the ketones, not much difference. In place of H, you are going to get another alkyl or an aryl group, depending upon your question. Then the another derivative we have seen, that is called as what? Amines. What it is called as? Amines. Please don't get confused with imines and amines. Okay, you can only have a notice what is the great changes are there between both. Amines se bere, imines se bere. But general representation of your amines, how we are going to write? RNH2. Yes. So when you're treating aldehydes with your amines, as I mentioned, first you have to write in this way. It's one the H na hortegiri yadu nitrogen jothe iruttala aduna. So when you're taking it out, so what will be left? NHR. Yes. So as I have said, this electrons will be taken by nitrogen. So H plus will be coming out. So this O minus will be there. By accepting the pi electrons, OH agutte. Iduna C mele positive charge bante. So nitrogen will attack this carbon. So now what happens? OH will be moving out. So in order to balance the valency of nitrogen, it will donate this lone pair of electrons, forming a double bond. In order to balance the valency of nitrogen, hydrogen bonded electrons will be taken by nitrogen. So of course you're going to get an important product which is called as what? Schiff's base. C double bond NR. General representation of a Schiff's base is C double bond NR. Yes. Similarly, with respect to the ketones, when it is treated with the amines, you're going to get as another Schiff base. Whereas the general difference, you can just see when you're treating with the aldehydes, one will be H. When you're treating with the ketones, in place of H, you will be having another alkyl group. Very much important. So one have to remember what? When you're getting imines, when you're treating carbonyl compounds with ammonia. When you're getting the Schiff base, when you're treating carbonyl compounds with amines. Coming to the next important part, we talked about another important derivative of your ammonia, which is called as what? Hydroxyl amine. That is NH2OH. It's a general representation of your hydroxyl amine. So as I mentioned, first when you're writing the reaction, take out one H from your N, which has been bonded with the nitrogen. So when you do the same process continues, so OH goes out. In order to balance the valency, nitrogen utilizes its lone pair of electrons. It forms a double bond in order to balance the valency of nitrogen. The bonded pair of hydrogen electrons will be taken towards itself. So H plus is going out, OH minus is going out, forming a water. So there is a reason, dehydration. Okay. So whenever such a small molecules, that is your water, they are all going out, they will be called as a condensation products. You'll come to know when we talk about a condensation reaction in this chapter itself. Okay. And so whenever it is happening, so the final addition product you're going to get is called as what? When you're taking aldehydes, you're getting what? Aldoxide. Similarly, when you talk about ketones and treating with a hydroxyl amine, yes, followed by a dehydration, the final product you're going to get as what? Ketoxide. Okay, ketone when it's treated with hydroxyl amine is called a ketoxide. Aldehydes when it's treated with your hydroxyl amine is called as what? Aldoxide. Generally, C double bond NOH is called as what? Oxides. Is that clear? So in all the cases, you can just see that the way of the product we have obtained is in this way, C double bond NZ. So when you talk about ammonia, we are having Z is equals to H. When you're talking about your amines, we are having Z is equals to R. When you're talking about hydroxyl amine, we are having Z is equals to OH. So one important clear thing we are going to know, the C double bond N character is existing in all of these reactions. And that is your final addition product, whatever you're going to get, it will be having this C double bond N. Only this Z will be going on varying. Okay. So whenever you're treating your carbonyl compounds with ammonia, you're getting imines. Whenever you're treating your carbonyl compounds with hydroxylamine, you're getting your oxides. Whenever you're treating your carbonyl compounds with amines, you're getting your Schiff's base. Okay. So in our next video, we're going to see another most important derivatives. Okay. The same scenario will be following, but only the difference is what type of a derivative we will be choosing. Okay. But important thing, the way of representation. Okay. Whenever we are talking about the derivatives, you just remember to write the derivative in this format itself. Take out one hydrogen which has been bonded with the nitrogen. So it will be easy for us to write our reaction and proceed and get our final product.